So today we're going to be doing greatest common factor. Now, I always struggled with greatest common factor versus least common multiple. And that even still would happen sometimes as an adult. Students often struggle with greatest common factor versus least common multiple. Have I done you my little analysis of how to know the difference? Okay, the reason why people often struggle with this is because the way that it actually works, or it actually looks. We have greatest, you don't have to write this, common factor. Now, you know that factors are small. You just had your factorization homework last night. Okay, factors are small, aren't they? Often, they start out small. So when you think of it being small, the thing is greatest kind of conflicts with that, doesn't it? Greatest common factor. So it's greatest common factor. Okay? Now, when you think of the greatest common factor, that's like saying hold on. I'll put her arms in there. Oh, not pregnant. All right, so we have the biggest member of the, the biggest member of the U.S. gymnastics team. Okay? That person, the person that is the tallest and weighs the most of the U.S. gymnastics team. Now, that would be the greatest of a small group, wouldn't it? Because gymnasts are like fun size. You know? That's what my friend who's much shorter, she says, I'm not short, I'm fun size. So that's like the shortest or the biggest person on a small group. And then you would have now think of, I got to put their feet the same. Now think of it as a comparison with the, whoopsies, come on, there you go. That's a bit of exaggeration. You know what? That's not realistic. There we go. Okay, now the smallest lineman of the Rams, standing next to the biggest, the biggest gymnast on the U.S. team. So you see how you're having the greatest of small things? This linebacker here, or this lineman there, would be the smallest of the big things, right? Because multiples, I'm talking the difference between greatest common factor and the least common multiple. Okay? The smallest lineman on the Rams is going to be still huge. Okay? I was the shortest one on my club team at Illinois State. I'm 6'3", for example. Okay? So I was the smallest in the big group because volleyball players are really tall.
So you're not talking like, I thought you meant like you have a big club, like not big. Like you're a small one on a big club.
Yeah, I was the shortest.
No, I mean like small one on a big club, not small one at a tall people. Who was like the tallest person?
How can I be more than one person? Of course I'm going to be a small in a big group.
You said, like, hang on. So there's a lot of people, so it's a big club, and then small.
No, I didn't say a lot of people. I didn't say a lot of people. I said a lot of people are tall in general in volleyball.
How tall?
But you're combining two different stories. Robert Waldlow from Alton? He's the tallest person ever lived.
No, on your volleyball team. I was trying to ask a question. Of course you
That was, I don't remember. It was 2002. All right. Finding the GCF. Now there are three different ways that we can find the GCF. We did one of them the other day that was listing the factors. We did another one which was prime factorization. Okay, with listing factors, prime factorization, and then also, what was the third way that we could find one of those? Bert? Ladder method. Oh, cursive. Ladder method. So as far as listing factors goes, let's zoom it in. Let's list some factors. So factors, we're going to go small to big. We're just going to put one there. Obviously, it's always going to be 1, but we're just going to put it in there anyway. Then I have, it goes into 2 because it's even. It goes into 3 because 8 plus 1 is 9, and 9 goes into 3. As far as 4 goes, nope, not 4. 5, no, it doesn't end in 0. A 0 or 5. It is 6 because 2 and 3 go into it. I have 7. Mm-mm.
Wait, hang on. Let's take this check. So, 16 minus 7. So is that right? So that'd be 9. No. So it's not divided by 7. Yes. How'd you get 7 minus 7? Because 18 times 2 is 16. 16 minus 7 is 9.
And it's not right. And it's not divisible. Mm-hmm.
Wait, so I'm right? No.
Yeah, it's not divisible by 7. You're correct. It's not.
No, because he said it was. I said it is.
That's what the. That was when you have 3.
No, because
3 digits. It'll work.
8 times 2 is 16. So you double that number and then you subtract by 7. What? Exactly. And then so 16. No, if the answer is 0 or
Subtract
7,
it from
then
the
it's
other digits.
Or you call 9.
So it's 1 minus
Oh, it all
Divisibility.
9 goes into 18. Okay, never mind. No. Never mind. You wouldn't subtract 7.
Okay, we're going to do the next one. So it is not even, so it isn't 2. It does go into 3.
15.
Okay? It does not go into 4. It does go into 5. It does not go into 6. It does not go into 7. No, don't shout hang on to me when I'm teaching. You can do that right now, and you can just do your own little thing rather than interrupting class. Yeah.
How would we know if it's divisible by 8 if it's less than 3?
If it's less than 3 digits, the way you would do that is if you'd have to do some math inside your head, knowing that 8 goes into something. For example, I know that 8 goes into 5. If it's divisible by 5, it's going to be the other end of that. Okay? Because, for example, 18 times 1 is 18. 2 times 19 is 18. 3 times 6 is 18. That's how you'd have to look at that. Rainbow method? Okay, stop tapping your feet. So we don't have 10. I'm going to have 9. Because 4 plus 5 is 9. Then we start going down the rainbow, I guess you could say. So we have 5, 3 plus 15, and then 45. So now we would look and see which one of these has highest, because 3 and 3 works, but there's another one that's greater, which is 9. Okay? Yep.
Did you see Fawn Sacrifice this weekend?
What?
Movie about Bobby Fischer.
No. Prime factorization. Now, this is what we did the other day. Prime factorization. We're going to pull these out. We want to use composite numbers when we get these out. Okay? We want to use composite numbers if we can.
5.
So I have 25 times 9.
Oh, we were doing factors. Where are we? Are you serious? Sorry.
And this is just 25 and 6. 2 and 3.
It's 25.
5.
It's 5 plus 5 plus 5.
Now, here's the way that you have to find out. So it says multiply the prime factors that they have in common. Make sure that you highlight this by circling it or something. That was my shoe. highlight it by doing that. So I'm going to list these next to each other. 225, 150. I had 3, 3, 5, 5, and I had 3, and 5, and 5. So I'm just listing those out again. Oop, thank you. It says multiply the prime factors they have in common. So I have 3 in common, 5 in common, and 5 in common. So I'm going to multiply the 3 that they have in common, 5 that they have in common, and 5 that they have in common. No, because that's a 2.
But you could just change the order. Oh wait, you're going to
That's a 2. Yeah. Yes, sir. Just add 225 and 150 divided by 2? To give you the correct answer? That might work in this one, but that's just to get that answer. Because no, that's not going to work every time. It just so happened to this time where it's 225 minus 150. No. Okay, I see what you're saying. No, that will not work. It did work this time, but that's also someone guessing how much change you have in your pocket sort of deal. It's like they could get it right. All right.
Why do people do the different types of 7s?
I do the 7 like that because this is a 1.
Yeah, I know, but why is there 2 different?
To be clear, the same reason that in writing that's a Z, so you don't think it's a 2.
Oh, that's helpful. So you just put a line through it.
Yep. Uh-huh.
I'll be using that.
Uh-huh. All right. So the upside down method, remember that only primes can go outside the ladder, okay? Only primes can go outside the ladder. So we're going to do 64 and 48. Now this method here is the fastest way to do it. However, it is not, let's see here. I'm thinking of least common multiple. I like this one the most. I'm going to take a, is that divisible by 3? No, it is not. So I'm going to use 2, 32, and 48, or we could do 4, yeah. But 4 is not prime, so we can't put it up there. Because I'm not listing myself. No. Yes, stop beatboxing. Or trying to beatbox. Yes? Why wasn't 54? You can only use prime numbers out here. You can only use prime. I'm left over with 4. Because when we do the least common multiple, you're going to want to make sure that you use prime if you use ladder method.
Wait, what's the other method called then?
So we have the ladder method and
What's that pyramid method?
now we are going to use the left side only. We're going to use the left side only, and it says multiply the numbers down the left-hand side. So we have, down the left-hand side, we have 2 times 2 times 2 times 2, which is going to be 16. 2 times 2 times 2 times 2, which is 16. We can highlight this one as well. Who, me? I'll explain the difference between those two later, but sure, it's your notes. Go, feel free. Yeah. A composite number, yes, but I'm telling you during least common multiple, which we're going to be doing tomorrow, you can only use prime on the outside because you might skip a factor. Mm-hmm. Yeah, it's fourth period has. I'll give them they can bring in a snack. Because we don't eat until 12:30.
Why can't I bring this?
Because you're not in my fourth period class. Nope.
No, but fourth period
It's like a snack break, whatever. Fifth hour has lunch right after that, true.
My science teacher doesn't bring us back in the period, but
Bring it with you to PE. Oh, and I don't know. Go to your locker between class, figure it out, I don't know. We're going to do GCF of the following numbers by listing factor pairs. I want you to do this. I'm going to do this as you do this. So if you're drawing a blank, then you can look up here. But if not, go ahead and go with it. This is in your head. 3 times. Mm-hmm. You only have to do one of them? Because you can recognize what is a multiple of the other things? Is that what you mean?
yeah, I only did one of them and I figured out it was 17.
Mm-hmm.
Well, I just set the answer up. Yes, the answer is right there. I think my teacher knew the answer.
Good. That's it. Any questions on those? Yes. Yes, there should be. Thank you. No questions, Your Honor? Now we're going to do the prime factorization method of these. So I'm going to split these three out. Let's see. Here we go. So I know that there's going to be x, x, x down here. So it's that one. This one's going to be 7 times 7 times x. This one's going to be -1, 42. So I have 2 times 3. Oops, -1 times 2 times 3 times 7 times x times x. Now, what is the method? What did you circle? The most important part about this option, what did you circle on the other side of it? Yeah. The common factors, exactly. So we have 1x, good. 1x, good. 1x. Another x. Nope, there aren't any more. Okay? Is there a 7? Yes, they have a 7 here, a 7 here, and a 7 here. Okay, we have a 3 here, but that's missing a 3 here, so we can't do it. So now I'm going to multiply 3 times 7 times x. There's no 3, Smith. Silly goose. 7x. Because 7 happens, it's in common with all of them. Wouldn't it be what?
Never mind. I thought we were multiplying for a second. I thought it was 49.
No. -1. Please stop tapping your feet. So we're going to do multiply the common factors together. And how many show up there? Just one. Multiply prime factors they have in common. Oh, sorry, the 2. So 2 times 3 is 6. Oops. Yeah, forgot about that -1. Negative.
Hey, what do we do about the negative on the bottom of
-90. Okay, let's start number 9.
Oh, I was right.
Yep.
Yeah, because that's one.
Upside down division. So we have 135 and -90. 135 and -90. We have 1 plus 3 is 4 plus 5. Salud. So we know it's 3. 3 works. So what would that be? That's 15 short of 150. So we're looking at 45. So we have 5, 3, 3, 5, 3, 3, and -2 on the outside of it. But what do we need to do for this method? Yeah. Multiply what? Which numbers?
The ones that are
Outside the box? More specifically, left side. Good. 3 times 3 is 9. Times 5 is 45. Okay, left side of it. Now we have one with a whole bunch of exponents and variables. So I know that there's a 2 that goes into both of those. 21 b to the 4th. And this would be 25, 26, 27. B cubed, 27 and 21, do they have a common factor? 3 times 7 and 3 times 9. Also, there's 3 b's that they have in common, right? Because what would happen if I did 7b to the 4th divided by b cubed?
It would be 7b.
7b. 7b, because you remember, Seven B. And that's just 9. Yes, sir.
A on how 1 equals 2.
So A times 3 times b cubed. Sorry, 2 times 3 times b cubed.
Why are we using b3 and not b4?
Because if I were to take
Because it makes no sense.
Can I draw a line through my B?
Oh, so use the smallest exponent.
exactly, because you're trying to take, you can't take 4 b's away from b cubed without changing it.
Well, that'd be a negative.
Because that would give you this. You would have
Negative exponent.
a negative exponent.
And then that would be really hard.
So 6b cubed.
Wait, would that just be B? Oh, wait, it's negative 1.
Yes, ma'am. Why does it 9? Why does it what? Why doesn't it have a b? Because what we did was 9b cubed divided by 9, or divided by b cubed.
So you always use the smallest possible.
That way you don't have a negative exponent. Please stop tapping your feet. Thank you. Wish I had a carpet. Yes.
On the top of the page, what is the answer for the top one?
Oh. Yes, if there are no numbers in common, GCF is 1. Because it's yeah. Yes. No? Okay. Yeah. No, it's going to tell you on, let's see here. Page 192, 12 through 36. So let's see what it says on page 192. Okay, I kind of don't want to call on you because I called on you and you put your hand down and turned around. One. So we have 12 through 36. Stop talking, please. Third. That's a typo. Hold on. 12 through 36. That might have not recorded correctly. I'll get it down. But notice how it doesn't tell you which to use. Okay. It doesn't tell you which to use, so that means you can use whatever one you like. I'm going to get